Hello everyone. Today we are going to study about furans. Furan is a heterocyclic compound and it is five-membered compound with a heteroatom oxygen. So the first thing is we are going to study about the structure of furan. Um, Furan have two double bonds and one lone pair in conjugation, which makes it aromatic. So the first property of furan is it is aromatic. Furan has four carbon and one oxygen that you can clearly see from the structure, and all of those are sp2 hybridized atom. And since sp2 hybridization is planar, so the furan ring is planar, and each atom contains one unhybridized p orbital which is perpendicular to the plane of sigma bond. So it results in the formation of pi electron cloud above and below the ring structure. And since the p orbital are parallel to each other, they facilitates the overlapping of p orbital with each other. And the total number of pi electrons are 6, 4 from the carbon atoms and 2 from the one of the lone pair of oxygen atom. And this results in the fulfillment of requirement of Huckel's rule. Uh, Huckel rule say that you should have 4n plus 2 pi electrons. So in this case we have 4 plus 2, that is 6 pi electrons. All of them are in same plane and they are in conjugation with each other. So we can clearly say that furan is an aromatic compound. First synthesis name reaction for furan is Paal-Knorr synthesis. Paal-Knorr synthesis we have already studied in pyrrole also. So in case of Paal-Knorr synthesis, 1,4-dicarbonyl compound reacts. In this case, in the case of pyrrole, we were reacting 1,4-dicarbonyl compound with ammonia, but in this case, we are just acid catalyzing this. Sorry, we are doing dehydration of this compound using acid as a catalyst, and this results in the formation of our furan. So let's see the mechanism. In the mechanism, you can clearly see that we have a 1,4-dicarbonyl compound, which in presence of acid forms OH positive here. One of the carbonyl oxygen takes proton from the solution and forms OH positive, and this facilitates the bonding of this carbonyl oxygen with the protonated carbonyl carbon and results in the cleavage of pi carbonyl bond. So what we have gotten here, we have gotten a 5-membered cyclic ring with a double bond and one OH which is substituted here. So this structure, this 5-membered structure which we have obtained is not stable. In order to stabilize it, it will eliminate one molecule of water. And from the fourth structure, you can clearly see that the proton is lost and one water molecule is being released here, resulting in the formation of aromatic furan. And since it is aromatic, it is highly stable. This mechanism is for substituted furan. Second synthesis is phased binary synthesis. In this synthesis, alpha haloketone reacts with a beta ketoester in the presence of a base to give furan. And in this case, we are not taking ammonia, we are taking NaOH, stronger base. So our alpha haloketone is reacting. Our alpha haloketone is reacting with activated ketone, a similar kind of reactants we have seen in case of pyrrole, but there we had ammonia instead of NaOH. Either we were using ammonia or we were using primary amine. So the difference is, in the case of furan, we are taking a stronger base. All right. So what happened in the mechanism? Your activated ketone reacts with OH negative of the base. I'll show you the mechanism. So what is happening in the mechanism? Your this activated ketone is reacting with OH negative and in turn facilitates the elimination of water. How? This OH negative extracts the H positive from this carbon and here results in the formation of a carbocation. And since won't carbocation will have a nucleophilic attack on your alpha haloketone. So in this case, your this cationic carbon will attack on the carbonyl carbon and form a bond. So this kind of structure is formed, and there is a possibility for the formation of a five-membered aromatic ring. So the further rearrangement occurs, the proton release occur. This carbonyl oxygen attacks the carbon which have chlorine and eliminates it. And it forms a five-membered ring here, but it is not stable. So in order to stabilize it, elimination of one water molecules take place here, and you get a aromatic five-membered substituted furan. Now next thing is another synthesis, and this is done by